Today I have a module from an Intel Paragon supercomputer. Now, I actually purchased this thing simply to get a hold of more ceramic ICs for my collection. These things were going pretty cheaply on eBay. I think I paid like 30 bucks for it, which is a pretty good deal for several large ceramic ICs. There's actually more underneath this board. But I thought I'd talk about this board a little bit before I start pulling off chips. Paragon is kind of hard to get too much information on. This is listed as an MIO board, which apparently is just like the multi-IO that this provides. I think it's Ethernet and possibly SCSI and maybe serial. Now, the CPU module underneath it is actually one of the newer ones. This is an MP3, a multi-processor 3 module, and the initial ones had fewer chips. I think they just had the one Intel i60 per board, so this allowed them to install up to like 4096 CPUs into these things, which are Risc based processors running at 50 megahertz. These are the XP versions. They were never very successful compared to the i960, which was an earlier design, and even that wasn't that successful. It's on a bunch of RAID controllers. Occasionally you find it in hardware as a main CPU, but for the most part they are a very niche product and never really took off. This is designed to install into a big rack case, and it's got this high density connector, but it doesn't have all that many connections to it. So it seems a little unusual that there's very little actual interfacing, especially since a lot of this will be power, because these things are going to chew through a fair amount of power. So you could probably assume like this much of it is power, and you're going to just have a few data connections. And the I/O board is simply an add-on module that connects through this long, thin connector. On the front, we just have little locking latches. I think this is an AUI connector for Ethernet, just based on some of the chips I've taken a quick look at. I think this is serial, and this is probably SCSI. Got a couple of indicator lights and the MIO logo. Underneath the I/O board, you can see there's these huge LSI ASICs, along with huge banks of DRAM and a whole bunch of GALs and all these FPGAs, and the whole thing is just ridiculously overly complex. I mean, who knows what this thing was doing? I mean, it's a multi-processor system, so what exactly is all this specialized stuff doing other than linking the CPUs together with the memory? I'm not really sure what all the hardware does, unless these are simply memory controllers, and they're massive. I mean, these are big ICs, and you have all these FPGAs, and this thing is just loaded with PALs and stuff. But this is probably all for the I/O, because I don't really see anything that specifically looks like a SCSI controller or anything. I mean, this looks like an Ethernet controller, but I'll look at the parts later. So I'm thinking that this is probably just handling all the interface to the CPUs, and it's also handling possibly some of the I/O. This is one of the 3 Intel i860 XP CPUs. Now, these are actually second generation chips. The initial ones were called the XR. The second generation ones basically added a bigger cache, support for level 2 cache. It also ran at a higher clock speed. I believe these ones are 50 megahertz. I don't think the 50s were available on the first gen models. This large chip between the 3 CPUs seems to be something gluing all the CPUs together. It's possibly some kind of bus controller or something. You can see it's got like a little lug heatsink on it and rather large ceramic caps on every corner. But this is the LSI L1A7988. No idea what it does, couldn't find any information on it. There's a pair of these L1A6634 chips from LSI. Again, these things are ASICs of some description. It says DP on it, DP ASIC, so it probably has something to do with the DRAM, but I'm not really sure, and I can't find any information on it. This one's kind of got goop and stuff on it, so this is probably going to be one I'm going to open up and get some die shots. This is one of the two large banks of DRAM. It's all DRAM from Fairchild, and they all supposedly contained 4 million words at 4 bits. So I'll let you do the math and convert that, but it's not a lot of memory. And there's 2 sets of 4, so I'm guessing it's actually joining together to make a larger interface. The interface between the 2 boards uses this rather interesting connector with these large plates as opposed to just all pins, and I'm assuming they're all ground connections. It's rather long, at least 100 or so, a couple hundred pins. And this is what it joins to. You can see the little gaps for the plates in the middle, and then you got all the pins, and it's rather hard to disconnect because of the length of it. You need a lot of force to remove it. There are a whole bunch of these Flex Logic KU-FX780-10s. These appear to be FPGAs, but I'm not 100% sure. I wasn't able to find too much information on them. There's a moderately sized Xilinx XC3190 on this board. This is probably interfacing to the board on top, since I don't know what one Xilinx FPGA off to the side is doing, unless it's all just part of the memory controlling circuitry. But it seems like there's just so many of these GALs and various FPGAs. I don't know what all of this is doing. It just seems like there's just so many FPGAs on this board, when in theory all it's doing is joining 3 CPUs, linking to the I/O board, and controlling the memory. If anyone has any more details on this board, like why it's so complex, other than it just requires a lot of external circuitry to interface with these things. I mean, that could just be it. It just needs a lot of large memory controllers to interface with just one bank of memory, but it seems like it's a little overkill for what it's doing. The MP3 node board. Now, there's a little 18 megahertz clock crystal here, and there's also a little 4-pin connector. I'm not sure what that's doing. It's just a little pin header with 4 pins. And yeah, it's just off in the corner. It's towards the front, so in theory you could plug something in and run it out, but it seems a little weird. It's probably just for diagnostic purposes. Although hard to read with the fiberglass in the way, you can actually see it's 12 layers, so this is not a cheap board. The I/O board is 8 layers. All the CPUs are actually socketed. They're all inside little turn pin sockets, and they're all individually placed. I don't know how they actually manufacture this, whether or not these just simply wedge in and then they're reflowed, or they're actually somehow mechanically held in place with a jig and then reflowed. I'm not really sure how they do that. I imagine they just wedge in, but you can see each one of them is actually set up like this, and they are going to be very difficult to remove. Probably a bit easier than the standard sockets that have plastic all in here, because you can probably get tools in and pry them up. But either way, these are going to be very difficult to remove. This is the one bodge on this board. There are 2 pins that have been swapped using a little mod wire. Now, I've seen pictures, some of the very few pictures that there are available on this board. They're on Wikipedia, and they actually have mods everywhere. So there's presumably a much older version of these lying around. But this particular one looks like a somewhat later revision where they fixed most of the issues. One more bodge, and I think that's it on the entire main board. And it has a little Tech Go logo. I don't know if they're a subcontractor or if they made the board or what. But yeah, Tech Go. Well, it appears these are flash chips. I'm pretty sure that's the little Intel flash logo. So let's see if we can get one of these off. Yeah, these are little flash modules, presumably with the even and odd memory, I guess. These are U100 and U200, and they actually are labeled U100 and U200, flashed in 1994. Let me see if my memory reader can actually read these things. Turns out I can read them with my programmer, so the U100 IC contains lots of strings mostly. Looks like it's related mostly to diagnostic stuff like testing the memory, whether or not the SCSI controller is present, doing tests on it, doing tests on the DRAM, all sorts of stuff. It looks mostly like a big bank of strings, although there's probably some code in there. The U200 chip has basically nothing in it. Almost the entire flash memory is clear, except for a few sections of random characters, so it's probably just configuration data. There were two more flash chips on the I/O board, so I read those, and they just have gibberish. So my guess is that they're simply just code for the Xilinx FPGA. Moving on to the MIO board, pretty complex with the millions of PALs, it seems. The endless sea of smaller ones. I think these are all like PALs, or these might actually be bus drivers. I'll have to look them up. Anyway, I mean, it's mostly just PALs and gals, and then there's a little bit of what appears to be SRAM and a rather large Xilinx FPGA, the XC4003, which is in a nice ceramic package. And that is about it on this board. I mean, there's not even any passives on the back. It looks like there's space for another SCSI connector, along with a whole bunch of ICs that presumably handle all of that. First up is the EmuLex, whatever, 2400121, which appears to be a SCSI controller because, well, it can't really be anything else, because what else would be controlling the SCSI interface on this thing? And lastly, we have an N82586 from Intel, which is an Ethernet controller, which does confirm that this is in fact an AUI port, which of course is an old school way of converting, having a standard connector that you could convert into either fiber or coax or twisted pair. This LM1951, which is a 1 amp solid state switch, has no attachment to the board. They did actually bother to remove the solder mask and put a hole in for the screw, but they didn't actually bother putting in a screw, which is a little bit lame. There's also a few jumpers on this board. They don't have plastic clips on them, and I think it might actually, I think it's soldered or crimped into place. Anyway, yeah, they're just standard jumpers. Oh, and it looks like there's space for LEDs, status LEDs here. Well, that's about it for this board. Now the fun task of trying to get these damn things out of the sockets. Now, I used to have, it was for smaller PGA packages, but I had this tool that was like a clamp, and it would clamp onto the socket and had another clamp that would go, you'd slide it in from the side, and it would go underneath the CPU, and then it had a big wing nut that you would turn, and it would hold the socket while pulling up the chip, and it would just pop it right out. It was actually from, I think it was for part of the a kit for Daystar CPU upgrades for old Macs, where you'd pull out the 68030 or 020 and then install their own board inside that socket. I don't have one that will fit this, and I don't have that little one anymore, unfortunately, since I sold all my Daystar upgrades a long time before starting my channel. But I might be able to find something that does the equivalent. I didn't see anything immediately on eBay, but a couple companies do make like really fancy ones, but they're like $300, so I'm gonna have to try and find a different solution other than the traditional just slowly pry it up, which is not only very time consuming but can easily break the chip. So I'm probably going to start with this one since it's in bad shape, and I'll just try and get that off. And I'd like to take the heatsink off one of these XPs, because I'd like one with the heatsink and one without, but I don't know how badly they're destroyed under there, because usually they use like really nasty epoxy that just ruins all the text. Well, turns out all you needed was a little flat blade screwdriver, and that was good enough to get all the ICs out with not much fuss. My guess is it's all because of these high quality turn pin sockets. They just came out really easily. I mean, they were secure, but I mean, once you work them out, you could really tell that these are high quality pins that they're using. And now we can see the bottom of them, the ICs, so we can get an idea of how big the silicon inside is. So this is the little controller thing that goes between the three i860s, and you can see it's rather large covering, and then the i860 itself, and one of the memory controllers. So they're all rather big, and wait a minute. I didn't actually notice that before. This is crooked. They put this plate on crooked. Anyway, yeah, lots of gold in these. The good news is if I open one of these up for die shots with the microscope, I can just sell all the, the cap and the IC, the actual IC itself, and just basically get my money back almost, because I really didn't pay much for this thing. The only thing left will be to take the Xilinx chip off, but going through an 8-layer board, and these look like pretty small drill holes, so this might be a bit difficult even with my rather nice Heiko desoldering iron. It's actually been quite some time since filming the first half of that video. I actually shot that around Christmas, and now it's like almost June. But yeah, it takes me a while to get videos done sometimes. Anyway, I finally bought myself a microscope. So now we'll take a look at the ICs which came with this. Now, the first one I have up is the NIC, which is the big ASIC between all three CPUs. So theoretically, this is interfacing all three of them and providing an external bus to communicate with the rest of the computer. So I usually like to just get kind of an overview of the board. Now, I am using an AmScope microscope. This is a trinocular microscope, which has a third port at the top so you can plug in a camera. I use two different types of adapters for my camera. One is just an empty hollow adapter. They're like 20 bucks or something. And it is pretty good when you're trying to get like an overview, because what the other adapter I have, which is like $100 one with optics, what it's basically doing is acting like a teleconverter, and it's cropping out the corners. So a side effect of that is that the optical quality is somewhat, it's kind of like a trade-off. You lose the vignetting on the side, but you get a narrower field of view because it's basically magnifying the center of the image. So when I like to do these overviews, I usually start with the just free air adapter because it provides a much wider image. Even using my lowest magnification objective, none of these will get a full die shot. It's just, there's just way too much space. You just can't zoom out that much. So I usually do macro shots for those using just my standard Sony 90mm macro. But with this 4x objective, this is actually a very nice objective. This is an Olympus one. I like to get just an overview to get an idea of what's on this chip. Now this looks like it's a programmed gate array, because there's all these sections with these black marks, and some of them are missing. So I'm guessing this is like a mask of some type that they're programming. I mean, I'm no chip designer. What's going to happen as I move around is it's going to lose focus sometimes because the IC is not perfectly level. I took the bottom off the IC, the cover, but it's still embedded in the ceramic. So I actually have the entire IC on a microscope slide in the whole package with the heatsink on some blue tack. So it's not perfectly level. I won't be able to get super close on this one because my objectives get too close and they bump into the sides of the ceramic carrier. So one of the things I like to do is start off in the corners, because there's almost always a name or a part number on it. So let me switch to my 10X. Enhance. There we go. So there's some information on it. Now it's actually hard to get all of these letters in focus, letters and numbers in focus, because they're on different layers and the depth of field is so narrow that it's really hard to actually get all of it in focus. See, you can see some of them going in and out. part number 17988, and there's some test patterns up here, but unfortunately I can't really get to them because if I go to any higher magnification, I start fouling with the ceramic carrier so far into the corner. So what I'm going to do is I'm going to go to a center section with them, something more in the center like this. Yeah, it looks good. Zoom out. I'm going to switch to 40 and see if we can get close with the 40. We may not. We may just bump into the chip because it's... Oh, there we go. Okay, so it does look like these are cut in some way. It's a little hard to tell because my 40X and my 100X, they just came with my M-scope, so they're not the greatest of optics. My 4X one is actually a really high-end fluorite Olympus objective, so that one looks fantastic, but unfortunately it's just too low of a magnification. So yeah, it's really hard to get this completely in focus, but it looks like it is actually, they are actually cutting these. So this is probably some kind of mask ROM that they're doing some I don't know if it's laser cut because it was the early 90s. They may not have been laser cutting chips on this scale. So I think it's probably something in the process where it just does something to these. There are whole sections of this repeating pattern, so I think this is probably cache or like SRAM because it's very repetitive. So it's probably buffering something. Let me zoom back out to the 4. It's probably got a FIFO or something in it to just handle all of the data coming in. There's 8 of them, so it's probably... maybe it's multiple connections to it, because I'd imagine it's a 32-bit bus. Yeah, so there's a couple big banks of this customized logic, and then it's just these large banks, which again I think are just memory, and then they're all interconnected with these again customized, seemingly customized pieces. Now what I've done is I've just sprayed this with alcohol, so it's not going to be super clean, but should be fairly clean. This is where all the bond wires are, or at least on this side. These are probably like bus drivers or something. I flipped the chip around so we can get a better view, and this is apparently a compacted array, and it's got a little TM. Okay, all right, we won't copy it. Don't worry, it's your registered trademark. And yeah, this is these 5-digit codes seem to be LSI part numbers. So this is the what is it, the 16634. It's 1991. And there's another array of these little patterns along the side. They must be for like calibration and stuff because they're all just geometric shapes. Just tons of logic, I'm guessing. So yeah, I think that the only thing these memory chips are, or these ASICs are basically just a shrunken version of a whole bunch of just separate logic that they were using. Moving on to the Xilinx, this is the FPGA, this is the XC4003. This is a very densely packed chip, but there's almost no features on it because it's, unique features because it's just a lattice of the same fabric over and over again, essentially. And this one was actually kind of dirty, so I had to do like a little bit of extra cleaning, and it's kind of grungy. I don't know why this was so dirty. I think maybe it just got some flux on it when I was removing it. Sometimes these the gold cover on them, it's very stubborn. That this high temperature solder they use is very difficult to get off sometimes. So it helps to melt it or mix it with some regular leaded solder, so sometimes flux and crap gets in there. But there's not much on this chip other than this massive lattice. 1991 Xilinx. Oh, it's pretty clear. Xilinx logo. Hole 00 ALA aluminum layer, I assume. And what else we got along the edges? This is where the only kind of interesting stuff is on this chip. Other than that big central mass of who knows what. Well, I mean, it's all just the cell logic cells and stuff, but you know, identifying individual stuff is a little beyond me. Looks like a layer count at the middle or on the corner there, and these probably are test pads. Okay, so I've coated the top surface of the chip with oil. It's a special immersion oil, which you need for 100x or higher magnifications. You need it because basically gives it a consistent surface to transmit light through, so you don't get any weird effects. Okay, so that's where the chip is. It's very hard to focus at this distance. Okay. Well, as expected, pretty much anywhere you go on this thing, it's pretty much the same. It's just this kind of repeating fabric, which is to be expected on an FPGA. And those look like vias. Very, very tiny vias. Well, let's move on to the next chip. There's not much to see here. Okay, so now I've got the DP ASIC in the microscope, and I think this is like basically a memory controller of some type. So I have the optical converter attached, so it won't be as wide a view. But this thing seems pretty uniform. It looks like it's probably just a whole whack of just basic logic, and it's just using it to replace a whole bunch of individual chips. They probably had like a whole bunch more pals and gals on this thing or another FPGA, and they just replaced it with these big memory controllers. It looks like it's just very uniform over the whole thing. Possibly some customization on it. Those are all the little test patterns. Last but hopefully not least is the Intel i860 Risc processor. And these ones, this particular one that I opened up, it's in pretty bad shape because a whole bunch of solder splashed onto it. So there's a whole bunch of marks and stuff. And you can see I sprayed it with alcohol, so parts of it are still drying. Let me give it another spray to at least make it even. See the little bubbles? All the little bubbles. It does make the image a little clearer because the top is one constant piece of wet surface. And moving along, we have, these are probably the caches. There we go. Intel 1988, 1990, 8860 XP. Test patterns in the corner of the chip. The bottom section. What's that? No. And moving along. There's some writing there. Oh, there's more test patterns. Moving through the chip, there's just the standard stuff of a CPU where you have like the arithmetic logic unit and all the caches and stuff like that. CPUs are generally fairly complex in chip design, so you have a lot of interesting patterns and different shapes along the surface. This looks like it's the cache. Well, I think that's about it for the chips with this thing. I really liked taking a look at this board because it, you know, you don't get to look at like supercomputer level stuff every day. And, you know, more chips for my collection is always a good thing, especially when there's duplicates, so I can open up a couple because I do like taking a look at ICs.